Hey guys, welcome back to Transmath 2. Today we are going to do half of lesson 11, half of lesson 12, but your workbook pages will reflect this as well. So in the first part of our lesson, we're going to talk about how we can use an area model, which is like a shape like this, to build number sense about fraction, addition, and subtraction. So let's begin with a rectangle on this grid. The rectangle covers 24 square units. There are 24 squares in the rectangle. We can count these squares from 1 to 24, or we can count 1, 2, 3, 4 across the top, 1, 2, 3, 4, 5, 6 down the side, and 4 times 6 gives us 24. Now we're going to divide this rectangle into two smaller rectangles, rectangle A and rectangle B. Rectangle A, when we count, covers 12 square units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 square units are in rectangle A. We can write a fraction that names the part of the large rectangle that is made of rectangle A. Our fraction would be 12 out of 24 because rectangle A covers 12 units, but there are 24 units total in the entire rectangle. Then we would use what we know about equivalent fractions and also name this part 1/2. 12 is half of 24. Rectangle B also covers 12 units. What fraction could we use to name the part of large rectangle that is made of rectangle B? 12 out of 24. Now that we've used an area model to name the fractions, we will write addition and subtraction problems about the area model. Because the large rectangle, or the whole thing, has been divided into two parts, rectangle A and rectangle B, we can write this fraction problem with addition. We can also write a fraction subtraction problem by asking, is there a difference between rectangle A and rectangle B? The answer is no, because the difference, or when we subtract these problems, we get a 0. So there's no difference, they are the same size. Let's go back to our original large rectangle before we cut it into pieces. And let's change the parts of the rectangle slightly. Now, rectangle A is smaller than it was before, and it covers 8 square units. Rectangle B covers 16 square units. Now we're going to write a fraction subtraction problem by asking what's the difference between rectangle B and rectangle A. We want to subtract. If we want to know the difference, that means we are going to be subtracting. The fraction that names the part of the large rectangle made of rectangle B is 16 over 24. There are 16 square units in rectangle B, and in the entire rectangle, the large part, we have 24 total. So that would be our fraction for rectangle B. The fraction that names the part of the large rectangle made of rectangle A is 8 out of 24. There are 8 total square units in rectangle A, and there are 24 square units in the entire rectangle. Now we can just subtract to find the difference. 8 out of 24. That means that rectangle B makes up 8 out of 24 more of the large rectangle than rectangle A. In the second part of our lesson today, we're going to move on to the beginning of lesson 12, and we're going to talk about least common multiples and why it's important. When we add and subtract fractions, it makes sense to keep the denominators as small as possible. Let's look at our example problem 5/6 minus 7/9. To solve the problem, our first step would be to find a common denominator. One way to find a common denominator is to multiply the denominators. Because the denominators are 6 and 9, we use our multiplication fact 6 times 9, or 54, would be our common denominator. So we then multiply our common denominators, or our numerator and denominator of 5/6 by 9 to get 45 out of 54. Then we would multiply the numerator and denominator of 7/9 by 6 to get 42 out of 54. Now we subtract to solve the problem. We get 45 minus 54, 45 over 54 minus 42 over 54 equals 3 out of 54. The denominators were the same, so we were able to just subtract the numerators. The answer in this fraction has a very large denominator. We can use fractions that are easier to understand if we find the least or the smallest common multiple for 6 and 9. Let's solve the problem again using the least common multiple this time. We can find the least common multiple for 6 and 9 by showing the multiples on number lines. The number line shows that 18, 36, and 54 are all common multiples of 6 and 9. The least common multiple is the smallest of the multiples, the smallest number that we see, which would be an 18. So these are all of the common multiples of 6 and 9, but we want the smallest one. We can also use a table to find the least common multiple. Either way, the least common multiple of 6 and 9 is 18. Now that we have the least common multiple, let's solve the problem. Because 18 is the least common multiple, we will use 18 as our common denominator. Because 6 times 3 equals 18, we'll multiply the numerator and denominator of 5/6 by 3 to give us 15 out of 18. And because 9 times 2 equals 18, we'll multiply our second fraction, 7/9 by 2 to get us 14 over 18. Now we solve the problem. 15 over 18 minus 14 over 18 gives us 1 out of 18. So 5/6 minus 7/9 gives us 1 out of 18. Now let's use the least common multiple to solve an addition problem. We're going to be adding 1/2 and 2/5. Remember, we can use number lines to find the least common multiple. Or we can use a table. It's up to you, whatever works best for you. Remember, we're looking for the smallest number that these two have in common. Both methods in this example show that the least common multiple of 2 and 5 is 10. Now we'll solve the problem. First, we identified our common denominator, and this is the least common multiple of 2 and 5, which is 10. Now we will use multiplication to make each denominator a 10. So we took 1/2 and we wanted to get the 2 to a 10. So we multiplied 1/2 by 5 to give us 5/10. Then we took 2/5, and again, we wanted to get the bottom number to a 10. So we multiplied 2/5 by a 2 to give us 4 out of 10. Now we can add. 5/10 plus 4/10 gives us 9/10. So the sum of 1/2 and 2/5 is 9/10. We use the least common multiple to find the smallest common denominator of 2 or more fractions. That's it for lesson 11 and 12. Make sure you log on to Schoology and complete your workbook pages.